Let us explain about this problem. Take down. Find out the electric field observed between the two charges. You can write this in your question bank. QA and QB given as 3 microcoulomb. 3 microcoulomb means 3 into 10 power minus 6 coulomb. QB with minus 3 microcoulomb, that is minus 3 into 10 power minus 6 coulomb, separated by a distance 20 centimeter. R is equal to 20 centimeter. So that should be converted into meter. So 20 into 10 power minus 2 meter. Given the Q naught, the epsilon naught value. So this value is 1.5 into 10 power minus 9 coulomb. Okay, this is Q naught. Now based on that we had to find out the field. So the concept here is Q naught is in between the two charges QA and QB. So we had to find out the electric field at the middle. That is, it is not Q naught, you can put QO. So what could be the first thing? You have to find out the QO, that is in between QA and QB, and based on that we had to arrive at. Okay, right. So we know if it is a Q naught means, QO means at the midpoint, so it should be definitely R by 2. So we can find out first of all the interaction between this Q naught and that is QO and QB also. Then you have to find out the interaction between this, and based on that we can proceed. We have got already E is equal to 1 by 4 pi epsilon naught, that is the into Q by R squared is the equation for electric field E. And we know the value of the reciprocal of what? 4 pi epsilon naught, which is nothing but K, that is equal to 9 into 10 power minus 9. And we know the formula 10 power 9. E is equal to F by Q. So these are the formula we are going to use here. Now the electric field is given by 9 into 10 power 9 because we are discussing the interaction between Q naught and QB. So 9 into 10 power 9 into 3 into 10 power minus 6, that is the charge possessed by the other one, and divided by the distance. The total distance is 20. Okay, so half the distance means 10. So 10 into 10 power minus 2 meter. So we can introduce 10 into 10 power minus 2 the whole square, and its value is found to be 27 into 10 power 5. And we know the unit of electric field, which is nothing but Newton per coulomb. Now we have got the value 27 into 10 power 5. We can change this into scientific notation. So 2.7 into 10 power 6 Newton per coulomb. We know the formula, that is E is equal to F by Q. So from this we can find out F. Therefore F is equal to EQ. Are you able to follow? F is equal to EQ. So when F is equal to EQ means now the electric field is 2.7 into 10 power 6 Newton per coulomb, this much, into 1.5, that is the Q naught, is it not? So Q naught is 1.5 into 10 power minus 9. So it results F, that is equal to 8.1 into 10 power minus 3 Newton. So once you are able to find out this F, Now we can find out the electric field also. Okay, so this is the force of interaction between QA and QB. Okay. Let us discuss another important problem, and it's a kind of derivation. Let us compare the electrostatic force and the gravitational force. In the case of gravitational force, you have got the interaction between the two heavenly bodies and inversely proportional to the square of the distance between them. That is the gravitational force. In the case of electrostatic force, it is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. In both the cases, almost they are looking similar. Only thing is, instead of mass, we are considering charges here. But let us compare these two forces. So Fe is the electrostatic force, Fg is the gravitational force. Now we are going to show that this Fe, that is electric force, is much greater than the gravitational force. You may think we are talking about the heavenly bodies and that force will be huge. And when you compare the size of the electron, size of the heavenly bodies like Earth, Moon, etc., the size of electron is almost negligible. But the force of interaction experienced by these two charges is very high. It is much greater than the Fg, that we are going to prove. And it has got 8.2 into 10 power minus 8 Newton, whereas the gravitational force is 3.4 into 10 power minus 47 Newton. So it means the ratio between them is, that is Fe divided by Fg is equal to 2.41 into 10 power 39. So what do you understand from this? It means the force of electrostatic interaction, that is the electrostatic force of interaction is almost 2.4 into 10 power 39 times of gravitational force. You just imagine how huge it is. Now let us explain. So here I have got Q1 and Q2, these are the two charges. Simultaneously let us work out M1 and M2. These are the masses of two heavenly bodies. Now Fe is proportional to Q1, Q2 divided by R square. And in this case, gravitational force is directly proportional to M1, M2 and inversely proportional to R square. And we are introducing a constant by removing the proportionality. Here it is K. But in the case of Fg, it is gravitational constant. So the gravitational constant is given by 6.67 into 10 power minus 11 Newton per meter squared, Newton meter squared per kg squared. But in this case, it is K is equal to 9.0 into 10 power 9 Newton meter squared per coulomb square. Right. Now we are going to compare. Here I have the Fe is equal to K into Q1 Q2 divided by R squared. And what about this? Fg, G into M1 M2 divided by R squared. So here K is equal to Fe R squared divided by Q1 Q2, whereas G is equal to, that is a gravitational constant, gravitational force into R squared divided by M1 M2. The unit of G is a Newton meter squared divided by kg squared, whereas here it is Newton meter squared divided by coulomb squared. So in this case, K is equal to the reciprocal of 4 pi epsilon naught, where epsilon naught is the permittivity through free space and its value is given by 8.854 into 10 power minus 12 coulomb square Newton per meter square. Whereas the epsilon is permittivity and we know also through certain medium, whereas epsilon r is relative permittivity. So it means it is the ratio between the permittivity through some certain medium divided by permittivity through free space. Okay, right. Now let us proceed. So epsilon is equal to epsilon r epsilon naught. So we are discussing about the force through certain medium. So instead of epsilon, we can introduce epsilon naught epsilon r. So Fm is given by Q1 1 by 4 pi epsilon naught epsilon r into Q1 by Q2 divided by r squared. We know for vacuum epsilon r is equal to 1. So in that case, that is F vacuum is equal to 1 by 4 pi epsilon naught and Q1 Q2 divided by r squared. Whereas we can also write this in the form of what? Vector. So the vector form is given as F21 is equal to vector F21 is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by r squared and r1 to r cap, that is unit vector. Similarly 1 2, that is the force on charge 1 exerted by 2, the point 2. So it should be read like this. How to read this? F12 means what? It is the force on charge 1 Q1 exerted by charge 2. What about this? It is the force on charge 2 exerted by force Q1. Okay. So and this is the unit vector for this one from Q to Q1. So they should have the opposite directions here. For example, Q12 means opposite to Q21, is it not? Right. And now let us proceed. This F12 is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R2 squared. And for this 1 2, it is the opposite direction, is it not? So minus what? R12 cap. So we can compare this, and finally the force is also equal but opposite in this case. For example, you have got Q1 and Q2, whether it is from here to here or here to here. So these two forces are actually opposite, that is F12, F21. So that's what we have mentioned here. Okay, these two are equal but opposite because of the direction. Whether Q is influencing Q2 or Q2 is influencing Q1, depending on the direction and their distance. And that is why the electrostatic force obeys Newton's third law. See that? Every action has got equal and opposite reaction. Okay. So in this session we have understood clearly, that is Fe is much greater than Fg because of the k value difference, and that is why this higher value is given to the electrostatic force of attraction. Then we have also studied, that is how the Newton's third law can be applied in the case of electrostatic force also by these means. Okay, any doubt?